Okay, so this is lab number 10 for EET-250L. This is a micro-Lidar rangefinder. I think I named the lab Localization, and had a little bit about autonomous vehicles and so forth. It's not only required to know where you are on the surface of the earth, but you also have to take and know what your surroundings are if you're, say, a robot or autonomous vehicle, if you want to navigate around the physical world. So this is the little sensor, and there's a little chip here which has, if you look at it, you can actually see two lenses on it. It emits an infrared signal, bounces off of something that comes back, and look what happens when I take it and put something there. The display. This is the OLED display. Notice they're driven off of these two wires. So it turns out over here there's a SCL and SDA connector. The yellow wire goes to SCL. That yellow wire comes here to the SCL connector here on the OLED display and jumps over to the connector, the SCL connector on the micro-Lidar. Then there's a white wire here, SDA. It comes over to the SDA connection on the OLED display, and the SDA connection on the micro-Lidar. The other connections to both of these chips are power, red for the positive VCC, and ground here. Those are the two connections for the little micro-Lidar. They go over to this bus here. Red and black over here go to the power and ground of the OLED display, and then we get the power from over here with the red and black, red for +5, black for ground. So I've loaded the program in, and it turns out that right now you don't see anything. When you first load it in, what will happen is the little display will come up with an Adafruit logo on it. But what I could do here is take something like the bottom of a proto board, and let me hold the proto board over the, well, so what's happening? All of a sudden I lost my connection here, so that's not good. It was working as you saw before, and now it is not. So I'm going to pause and see if we get this thing going. Okay, so I ripped all the wires out and put them back in. Apparently there was some type of loose connection. What I'm going to do now is hold this proto board over the top of this, and you can see the display, and as I go down you see that it goes smaller, and I go up, it gets larger and larger. Notice that the resolution is 1 millimeter, and again it's pretty accurate. You really need a good surface to reflect, however, and I do have some meter sticks that are calibrated in centimeters, or 10 centimeters, excuse me, 10 millimeters equals 1 centimeter, 10 centimeters equal 100 millimeters, and I tell you it's pretty accurate. So now if I go real close here, I don't know if you'll see down to it looks like its accuracy gets compromised if you get too close. But anyway, you can see that it works. And again, this type of ranging it can be used, although Tesla says he likes radar and cameras instead of LiDAR. So this is a rather simple experiment, but easy to build, and gives you an idea of the fact that, again, we can have two devices on this bus. So the bus basically is the yellow and white wires here. We have two devices. It turns out that this guy here has a different digital address than this guy here. So the software takes and writes to the correct device for this to operate. Okay, so that's enough for this one.